Hi everyone. So my name is Faizan, and in today's class, we're going to discuss the very basic concepts about data interpretation. Data interpretation, you will see, is some aspects of quant which you did earlier will be useful here. So I am going to sort of talk about graphs firstly, and then I'll talk about introduction to some questions, and then I will maybe have time for mathematical reasoning. So let's get started. All right. So what happens in case of DI is that you have multiple data points, of course, and it can be in the form of a table. It can be in the form of a, let's say, bar chart. It can also be in the form of a line chart or a line graph. And then there is something called pie chart. So these are the different sort of the ways of how you can write data. Now the idea is what how do we approach these questions firstly, right? Now we need to be very comfortable with what is a table chart, what is a bar chart, what is a line chart. Once we are very comfortable with all of these ideas, then you will realize that you learn how to first interpret, you understand the information first, and then you go to the questions. So I'll walk you through all those steps. We'll start with DI, and let's see how to see these table charts. So imagine I have a table, and we can make it like a little bit fun. So maybe it's an ice cream shop I have. So ice cream shop. One is a naturals, other is just tell any name. I don't know if I'm right. Kianos, what's that? Anyway, let's assume something, or maybe Keventers. Okay, so there are ice cream shops. One is this shop, Natural, other is Keventers. Now I went and sort of had a chocolate scoop, or I can have a sort of let's say almond almond pista scoop. Okay. Now imagine in a week, this data is about a week. The number of scoops I have is 5. Here I have is 4. Here I have is 3. Here I have is 6. So this is an example of some information 5, 4, 3, which is represented in the form of a small table. So it's a very small table, and the numbers are all also fine. Now, if I ask you that, okay, tell me during the particular week how many chocolate scoops I had from Naturals, you will just refer to the data and you will tell me that, okay, you had 5 of them, right? So that's how you have to understand. If I ask you something about, let's say, number of scoops, almond scoops you had from Naturals, you can just say me 4. Then I can further build upon and ask you some questions based on ratios or based on percentage. Okay. Maybe what is the percentage of chocolate scoop in the total in the entire week? Then that will be 5 plus 3. And if I ask you what is the percentage of uh, chocolate scoop from Keventers, then you are going to refer to this 3 and then the total, right? So that is how you can sort of get into these questions. It's about ratios and percentages mostly. Uh, this is a very simple example where I have, it's like an SAT question actually, but tables can also be with a large number of data sets. For example, if I talk about, let's say, Delhi or any other city, you can take Bangalore. Okay. Delhi, we talk about the metros. So let's talk about metro. So maybe in the month of January and in the month of February and in the month of March, I can sort of number of stations, right? So many stations in metros. For example, in Delhi, you have Kalkaji. So I can have a Kalkaji here. some stations like Green Park, Kailash Colony, and I can list more and more stations. And then I can give you the number of commuters. So let's say 15,000. This is 18,000. This is increasing, right? So I can fill the entire table just on the basis of number of stations here. So you have on one side you have stations. On this side you have January, February, March, April, and so on. So different months basically I can sort of put on this side. If you choose to do this, what happens is that you get an idea about the number of commuters in a particular month from a particular station. So this will be a very large data set. It will not be, it will have multiple stations firstly, it will have multiple number of commuters as a data. And then this is something that you need to refer to answer questions. So this could as well be an example of a table chart. Sorry, data in a tabular form. So this is an example of a data in a tabular form. We'll move ahead to the next part. Let's say something on the bar chart. Now, when it comes to bar chart, some of you might be familiar. There will be certainly go back to your quant classes, geometry. We know that this is the x-axis, this is the y-axis, and this is the coordinate. Now, a bar chart will be something like a bar. What's a bar? It's rectangular in shape. So you have all these bars. Okay, there's this company. There are multiple bars that I can draw here. There are multiple companies saying that in the bar, protein bar, and so on. But anyway, I don't consume them. So, so what does do these bars represent? They do have a certain height. For example, the height is this much, the height is coming to this point, the height is coming to this point, and so on. So maybe if I talk about, maybe you can take anything on the y-axis, and maybe you can take a time period in the x-axis. So for example, if you want to take the months, winter months, let's say February or January, February, March, April. Okay. And then you have May even higher. And then you also have June even higher. So this is June, this is July, or May, June. You get the hang of it, right? So this is a bar chart that I'm trying to draw. Now in this segment, maybe I can have my income. So maybe my income is 10,000 here. My income is this is 30,000. This is 50. This is 70. 9. I'm increasing uniformly. Notice that. This is for every step, there is a uniform increase. So this is representing my income. Okay. And this is representing the number of months. So what does this indicate? If I were to look at this chart, and if I start from the month of January, my income is corresponding to the ceiling. Where does this bar chart end? So it ends at 50,000, and this will represent my income for that month. If I go to February, the bar chart is ending at this point, and then you just see where it is representing this data, and you get an answer for February. I'm happy about in June because this is showing me the highest. If it most likely is showing me 1,10,000, right? So I think figure is not so neat, but please understand that this part is the highest visually, and it corresponds to a number, and therefore you can use this bar chart to interpret the information about the income in different months, right? So that's how you sort of go about all these bar charts. Uh, Now, there are multiple questions that can be in bar charts. Usually, what happens is that in you might have questions that have some information in this bar chart, and you will have to look at them carefully and then use it to solve questions. So that will be at a very later stage. For now, we are just going how to understand what a bar chart is. Okay, a line chart is sort of similar. A line chart is quite similar as well. If I talk about a line chart, usually what happens is that in a line chart, one second. In a line chart, you will have lines and the same x-axis and the y-axis. So you have this x-axis and you have this y-axis. So you might have lines like this, like this. Just see how the lines are moving. Maybe this is temperature. Let's take sort of y-axis is temperature. This is like 10 degrees Celsius, 20. There is, I'm increasing it with the same uniformity. So it's 10 and so on, 10, 20 and so on. This is like January, so it's a winter month, February, but this is like 30 degrees. It happens. And then there is April, May, June, and so on. I think I should change the figure. Maybe I should do 15. 10, 15, 20, 25, 30. I can use eraser. So you have just a minute. You have 10, 15, you have 20, 25, 35, and so on. So what do we understand by this chart? See, usually what will happen is we look at these points. We look at these points. So wherever this is a month, January, February, you go to it. This is a month, March. So we are looking at these points because these points are giving me a coordinate for each month. So it is similar to the idea that if you look at January, you go to this point, it is 10 degrees Celsius. If you go to February, you go to this point, it is 20, more than 20 degrees Celsius. If you look at April, you go to this point, it's around 25 degrees Celsius. So the idea is that you can represent some information in the form of a line chart. And what is the benefit? If you represent the information in the form of a line chart, you can see that this is an increasing part and this is a decreasing part. Same, you can see this is a decreasing part, this is the increasing part. So it helps you visualize certain things, and that is the ease of it. You can visualize, okay, there has been an increase. You can see some patterns and trends, and maybe it will help you, right? This is how we interpret, this is how we understand what a line chart is. Okay, we'll go to the last part, and that is something called pie chart. What really is a pie chart? Let's see. If I make a pie like this, a pie as in imagine it's a cake. It's a cake which is sort of stevia based, so it's not sugar based. I mean, I don't know if you know stevia, it's natural sweetener. So this is a pie, and what I will do is I'll put some percentage figures. So I'll put 30%. I'll put this should be 45%, and this I can put as, or I can put this as 20. This I can put as 35. Okay, so if you add all of them, you'll get 45 plus 20 plus 35. This has to be 100% because it has to be 100% because this is a complete circle. So with a okay, now what do these represent? This is the share that this is the least amount that I had. So my name is Faizan, so I will eat this portion. This portion will be eaten by students, and this portion will be students by the friends of students or the parents of students. Okay, so this is just an example that I'm giving you, of course. So you see this pie chart, it is basically a way of representing some part of the pie. So this 20% is like 20% of the 100%. So it is like 1/5 of the entire area. If you see 20 by, you add all of them, 45, I mean 100% by from this part, you get 1 by 5, which means that Faizan is eating 1 by 5. Like I am eating what? 1 by 5 of the entire cake. Okay, but usually questions are not so interesting. They are boring in nature. You might have population, you might have votes, some boring stuff in a pie chart. So that's what you will see sometimes. You get a pie chart, you have to go with this understanding. What is the share? What is the area? That usually has some number, or you will have at times to figure out that number. And therefore, this is how you will go about understanding. Okay, so I've discussed four different charts, which is one is a bar chart, one is the line chart. You also have discussed the idea of a line chart, uh, and the line chart, sorry, I'm making a bar chart, and the bar chart is not any absolute number. It's actually a percentage number. So this is the percentage increase in population with respect to previous year. Okay, and you will also have a graph where will the population will decrease, of course. You have one more over here, and you have one more over here. Now, this is the percentage. That means I'm going to write some numbers over here. So maybe I'll write 4, 8, 12, 16, 20, 24. And the same I'll do with the negative side of y-axis. So I'll start with -4, -8, -12. So just see this bar chart. This bar chart is talking about population firstly. It's talking about this idea, which is the idea of population. So I'm talking about there is some population in the city X, and that population is going to increase on a yearly basis. This is the year 2025, 2026, 2027, 28. So I've mentioned so many different years, and I've also mentioned the percentage, not the absolute, of course. It's a percentage increase, and you can refer to this bar chart and see. Just take a moment to see and reflect if you can understand how what it is representing. And there's a question that follows. The question that is that on which year is the population highest? On which year is the population highest? So just take a look at this graph. Uh, I'll just pause and maybe attempt this, and then I'll try to solve. Okay, let's solve. Look, if you look at this bar chart, this bar chart has so many different figures for every year, and you also see some negative and some big numbers like this, and so on. If you look at this, it looks like this one is the biggest, which means that it will be sort of tempting to answer that this year 2030 has is sort of so showing you the largest population increase, not the increase, I'm sorry, the largest population in number, right? But it may be true, it may not be true. You do not know. What you're currently doing is you are sort of thinking of this because it looks the highest. We do not know that. You will have to, the way to solve this would be you have to make a table first. So you write year on one side, you write population number. This is not the percentage, this is absolute numbers. So maybe in the starting of the year 2025, if the population is given to you as, let's say I tell you the population is let's say 1 crore. Okay. I'll have to be careful because let's say the population is X, because you will have to deal with decimals, so I'm just giving it a variable. So the population is X before the year 2025. Now, if I write this as X, then in the next year, sorry, in this year only, you have a 12% increase. So I'll write 0.12x. Go back to your class. This is nothing but representing 12% of X. And then in the next year, which is 2026, I'm not going to work on this X. Rather, I'm going to work on 1.12x plus there's some percentage which is around 20. Let's take the rough figure 20. So then this becomes 1.12x plus 2.24. And that is like a big number, 0.224. So this becomes, yeah, sorry, this is the answer I'm writing. It becomes 1.342x if I'm not wrong, right? The idea is that you take this figure and then you add a 20%. And then you do the same thing for 2027, 2028, 2029, 2030, and so on. Similarly, what happens is if I ask you that these figures, right, what do they mean? Well, they can be deceptive actually. Why it is deceptive? Because this is happening when this has happened, which means your population increased. On that base, there's another increase, and on this base, there is a small decrease. So it does not mean that on this year the population is less than X. No, it might still be more than X. And that is a significant or an important point. Population here can be more than X, which is the starting population, right? This is an important point, and that is what I wanted to understand. So two things here. What bar chart might look may not be the real reality. You will have to look and read what does the y-axis represent. You have to read and then use your skills. Okay. So these are the questions that are commonly asked. And this is an example of a percentage increase. It's not an absolute figure. You are actually increasing the numbers based on the previous year's value. And therefore, this may not mean that population has declined from X. It may still mean that population has appreciated from X. Same can I tell for everyone else. And this does not mean that the population in this year is lesser than this year. No, the population in this year is higher than this year. Even though, look at this ceiling, it is ending here. So these are some of the points that you will see come across to you. And yeah, I mean, mostly these are able to be tackled. Okay, move on to the next question. This was a beautiful question because I like this question because it looks like oh, this is highest, this is lesser than this year, but all of that is actually not true. Okay, I'll give you one more question. Maybe I'll put a pie chart first. This pie chart is about the number of votes. So let's say the number of votes received by what, Trump, maybe 30%, Harris, maybe 40%, and some let's say Kennedy, maybe 30%. Now within this, if I expand, I can have just for Trump one more circle, one more pie chart, and then I can have with different states. Maybe this is some state, uh, maybe new. This is LA. This is some other state. This is some other state, Washington. So this is a split of all the votes between the states. That's what I'm trying to convey from this graph. So you might have a pie chart where this shows the number of votes received by three sort of political lead. I mean, what are they? Number of votes received by these three people. And then if I sort of take just one out of them, and then I want to split, okay, let me find out what are the different number of votes received by this person from all the states. What is that breakup look like? Then I can have one more pie chart altogether. So you will see that in pie charts, questions can be that you might have one pie chart or more pie chart. This is more like we are just getting started. So I'm giving you an example. This, how will you interpret is, suppose the total number of votes is, let's say, 10,000, which means this person Trump must have got 3,000 because 30%. And then this pie chart is going to represent all the 3,000. Now further, if I tell you the information about what can be to begin with, if I tell you the information about the highest vote in any state for Trump, highest vote in any state for Trump was less than 5,000. Okay, if I tell you that, how many states are there? One, two, three, four, five. There are five states, right? Do you think this statement is true or false? So there are this one, two, three, four, five states. The number of votes received by Trump is totally 3,000. Can the highest vote be less than 5,000? Yes, it can be less than 5,000. Why it can be less than 5,000? Because the total itself is 3,000. It was a very basic question. But if I just change the number, Can the highest vote received in any state be less than 500? This statement cannot be true. It's false. Why it's false is even if you have all the numbers, like you have the numbers like 490, 495 for all the states, I mean 496, 499, and let's say 400. Even if you add all of them up, this will not going to cross 3000. So this means that at least one state would have gotten more than 500 votes for sure, right? So this is an example of a question that I could have asked. Okay, I think so far we are good. So far we are good. We have got talked about pie charts and line charts and bar charts. Okay, I'll give you some mathematical reasoning questions. It's also as a temperature of 80 degrees Celsius. Degree Celsius or Fahrenheit, there does not matter much because you will have that in the graph as well. So maybe Fahrenheit is also all right. Now you put this into a refrigerator. You put this into a refrigerator, and what you notice is that the temperature inside of the refrigerator is 40 degrees Celsius. And then what you notice is the dish quickly cools at first. So it will sort of cool quickly, and then it will slow. Then basically it will continue to sort of cool, but it will slowly cool, but slow down as the dish, as it approached the temperature inside, as it approached the temperature inside the fridge. So this is the question. I think my handwriting is not so good, but I'll just read it out. So you have a dish which is at a temperature of 80 degrees Fahrenheit. You put it into a refrigerator, the temperature of which is 40 degrees Celsius. You see that the dish quickly cools at first. I mean, it quickly cools at first, which means you will just see talks about time, and then slowed down as it approached the temperature inside the fridge. So I'll draw four graphs. You have to choose which one would represent the behavior correctly. So you have degree Fahrenheit. So what, 20, 40. Remember the temperature of the refrigerator is 40. So this is the first option. 60, sorry, this is not temperature, this is minutes. Have a note at the first graph that I've drawn. Second option would be the same figures, but like this. The x and y coordinate would still remain same. You still have this as 80. You still have this as 60, and time is also same. But look at the way the graph is now. It is in an inverted format. The third option would be that you start with 40 and then it goes up. So I should not tell you what it behaves, and that is you to figure out. So this is the same x and y coordinate, 60 minutes, 120 minutes, but the way it looks is this. And the last option is that you have 20, 40, 60, and 80. And then it looks like this, which means that 60 minutes and 120 minutes. This is, of course, the temperature. So what I was saying is that you have four different graphs, as you can see. And can you determine which one would represent this part, which is what is shown you in the figure, sorry, in the question, that the dish quickly cools at first and then slowed down as it approached the temperature inside the fridge. So which one do you think would represent quick this? See, this is a straight line, which means the dish will continue to cool down at a uniform pace. This is not what the question told me. And this is actually about the dish increasing in temperature. That does not happen in a fridge. This is that you start here, but we know from the question that we will have to start at this point because the temperature of the dish, as you can see, the dish temperature is at 80 degree Fahrenheit. So you can't really start off at something like at this point. From which means automatically this has to be the right one. But otherwise, if I have to explain this, look at you can also look at starting point. Fine. What does it mean that this area is about what we discussed in the question? It is actually cooling down very quickly. The temperature drops from 80 to somewhere around 40 in just some minutes. But in the next time, which is another 60 minutes, it drops quite little. So what is the drop? The drop here is much sharper as compared to the drop here. And that is what the question told me, right? If you go to the question told me that this drop is much sharper and then this drop is lesser. So this makes the perfect, so this makes the right option. I have one last question. These kind of questions may come, I mean, okay, one last question, which is on a scatter plot that I thought I will share. This scatter plot is about consumption, and I'll put a y-axis and x-axis. This is annual per capita consumption of any grain, right? Let's say millets or maybe wheat or corn. I have years from here, and since 2025, which means I'll name it as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you will see that what I'm going to do is I'm going to draw some scatter plots. So I have these scatter plots. Right? Uh, this scatter plot, of course, tells me that, like if I look at this point, it tells me the per capita consumption in the year since this is 2026. I've given the name as 1, 2, 3 because the x-axis is representing years since 2025. Now, now what can happen in such a question? Now, it's little simple. Uh, in such a question, what will happen is that if I substitute the numbers x as 0, 1, 2, 3, 4, I'm going to get the value for y. Now I'll give you four options and then I'll go back to the question to help you understand. This is what y is as a function of x. Okay. Then you let me complete the option. All right, so we have the options in front of us. These are very confusing numbers, decimals, and so on. And let me also put the y-axis. So the y-axis can be, this is a starting point, right? So I'll put y as 5, 10, 15, 20, 25, 30, and so on. All right, what do you have to do over here? If you look at this scatter plot, my friends, this is an example of a parabola, right? This scatter plot, if you see, is an example of a parabola. Now, in a parabola, if you have an upward parabola, you cannot have these options because any upward parabola will have a positive x square coefficient. So these two options are ruled out straight away. Now, if I look at the very first coordinate of x, which is somewhere close to 0, let me substitute 0 over here and also over here. I'll get x is equals to 0 and y is equal to 0.968. And similarly for here, if I substitute the value of x as 0, I get y is equal to 968, which means that if I go back to the figure, this is 968, this is close to 1. What is, if I go back to the figure, for x is equals to 0, certainly less than 5, that I know for sure. Looks like close to 1, but it is certainly not 968. So I can mark this as the right answer. So, so in this data or in this graph that you see, you can have questions basis upon how well you understand the scattering of these points that you see. In this case, it was resembling a parabola. Hence, I could straight away mark this option as the right answer. So I hope that you like this class. Uh, Thank you so much for listening. See you again. Goodbye.